And I really appreciate to all of those people who have subscribed to our channel, Engineering with Sustenance. For all those who haven't done it yet, please go ahead and like, share, and subscribe to Engineering with Sustenance. And if you are interested in getting to know more about sustainable engineering, this lecture is actually the continuation of the first lecture, which was on sustainable design through green environment in the world. And now this one, we are more concerned how to design a green building. It's just an overview because complete design is will be taking a lot to discuss about, but let us see. But this will be a kind of more insight into how we design a green building and what procedures are involved. So this is just a talk on design of shell structured green building. As I said, it's an overview on the design aspect specifically, and let us see how it works out. So shell structures. It's really important to understand the concept of shell structures that are being used mostly in green building concepts. So shell structure is actually a curved, lightweight structure. It's a thin in that direction perpendicular to the surface. So if you have a paper and you just put a pen on that in the perpendicular direction, so it's that direction basically. So well, some of you might be thinking now how thin it can be. So there is no ruling that I found online or in any design manual which states that how thin a shell structure can be. So it can be as thin as possible, but there is no ruling on that. And let us give you some good examples that of domes, arches, and the cylinders that you might have seen in the normal basis. So basically, those are the shell structures. This is a very good example of a shell structure. John F. Kennedy International Airport, which serves the New York area in United States. So this thing, basically, we are more concerned to design this thing here. So these are the shell structures, and the same concept we will be discussing in this lecture as well. But concerning the aspect of green, green thing in there. So the project that I will be discussing is actually a continuation of the previous one. So if you guys need more insight, what was that project and how it is linked with sustainability, I would invite you to please listen to my first lecture, Sustainable Design, Sustainable actually Future Through Green Environment. And then you will realize this thing more in depth. So project sections, as any project is based on architectural design, structural design, heat ventilation and air conditioning design, is more specifically about the mechanical design, electrical and power supply, then plumbing, cost estimation, and project management, of course. But I am going to discuss only about the architectural design and structural design. So these two aspects I am more concerned about. So let us see how we can use these two aspects to design a building which can be rated as a green. So description of the project is really important. So that building was designed back in 2015. To be exact, I guess that was around about September or September or August, I guess. So that was the tentative site plan was made in Defense Housing Authority. That was in Phase 7, Sector Y, Avenue 14 in Lahore, Pakistan. And this building has 3 floors with a single basement. So for all of those people who are joining us from United Kingdom, actually the ground floor and 2 above floors, and then the basement is a separate thing. But for everybody else, it's 3 floors, including the first floor, which we the British says them that as a ground floor, but here in Canada and United States and mostly in other countries we consider it as a first floor. So this building is multifunctional because it's a shopping mall. So ground and first floor was serving as a shopping mall. So mostly the shops were all around the first and the ground and the first floor. And the top floor was considered to be an art gallery, conference room, and exhibition center. And then there was a basement in the a basement that was dedicated to the parking. The concept of that building that you will be seeing a lot in this presentation as I move forward was taken actually from a flower petals and igloo. So the flower petal, as you can see in this picture, is actually the five, I would say the 5 petals of a flower is when it blooms, I guess. So it's form a kind of this shape, which is actually the main concept in my building, like in our project. And this one, the igloo here, was used as a concept towards the arches inside the building. I will try to explain later on, then might be helpful to understand it in more depth. Site selection in this building was really a important task. It was the most difficult part of our project because we have to discuss the development and public transport areas. Because if we are going to design a project like a green project or any other conventional project in such an area where there is very limited access for the people to come, for example, villages, suburbs of the city, the so we will be losing a lot of money because people will not go there because it might be a long commute from their houses. So the site selection is primarily based on the public transportation access and the development. Then we have to consider the fact of low emissions and fuel efficiency in there as well, because mostly cities are the center hub for these kind of fuel and emissions, industrializations and all those stuff. So we have to limit these things because it's a green project, so we have to limit that thing. Parking capacity is more important because let me give you an example here. For example, if you see for the Pakistani people, there is one very very famous road called MM Alam Road. So most of the projects in there in that area is not built up because of the parking issues. So if the building is having very less parking, they will abort that project because people will be actually looking forward to see the shopping malls or see the actual building there, but they cannot park anywhere, so they might not be willing to go that place because it's a hustle. So we have to look forward how we are gonna put the place, the cars, the people, the transportation, and all those aspects when they are visiting over buildings. So natural habitat should not be destroyed. So for example, it's not like we are going to build a over project in such an area which will be a disaster to the environment, maybe the birds, maybe some kind of other animals, reptiles, anything. So you should be taking care of that, and the waste management and all those the other aspects is really really important. So considering all this fact is the the preliminary aspects of the design, how we're going to proceed into these things. So this is very very important. All of these aspects are very important to design any project, but it is not an exhaustive list. It can increase, it can also decrease, so we have to really look forward to that and put our energies into these aspects primarily. Starting from the architectural design of this building, that the project is under discussion, so you can see here. So green roofs for reduction of overheating and artificial conditional loads. So you can see that there was green land on the top of each petal, each limb of the building. So that was being primarily utilized, first one for the vegetative and agricultural purposes, and secondly, most important, to reduce the cooling load inside the building, which is the most primary aspect of the design. Albedo effect was implemented as well, which is the reflection of the radiations from touching any surface. So the more the radiation is going back into the atmosphere, the more less the building will require to cool the inner atmosphere. Heat island effect, considering the aspects of urban heat island aspect here, because the more the greener the area inside the building, the less will be the heat generated from that building, because it will be helping out to reduce the heat into the surroundings, into the vicinity of the building. So that's also helpful for designing a building as a green. Skylighting through the patio in the center for equal distribution of the light. So the patio in the center that I will try to show you in the later slides is being designed in such a way so that the light from the sun actually try to equally distribute all around the limbs of the building, which is actually the flower petal that we as we discussed in the start of this lecture. See, this one is the plans out here. We'll try to show you in a more depth. So provision of water fountains for evaporative coolings. Okay, have you guys ever thought why they provide the fountains around the building? So here is the answer. because they want to try to reduce the heat into that area. So when the fountains are being running into the place, into any place, I guess, so it will try to reduce the heat effect onto the surroundings, because the water will try to evaporate from the surfaces most often, and it will try to reduce the effect of heat all around the surroundings. So again, the concept of reducing the burden on the HVAC system inside the buildings. Proper landscape for aesthetics and cooling of environment, we have discussed that already. And this is just for this is really important onto every latest design is the building. We have to look forward to the emergency fire exits, and first aid boxes should be there to fulfill the requirements of the latest design by design provisions by any code. And provision of lifts, elevators, and proper circulation areas to fulfill the purpose of circulation into the shopping mall. So the area around the shops should be really, really, kind of easy access to different shops. So if there is a narrow access to different shops, the people will not try to come into that building, because people will be trying to bump into one another, which will be a hustle. We don't want to do that. So the thing that all around the shopping mall, the space should be so much vast that people can see all around, and they should be designed such that a person, if the person is standing into the center, he can view all around the mall, no matter he is standing on the first floor, second, whatnot. And shops with no congestion is really important, that considering the effect of anthropomological demands, so which is the time saving standards. So for example, if you want to go out from shop number 10 to shop number 35, it should not take you more than, like, I guess 2 to 5 minutes. So you have to save your time. People try to visit the shopping malls as quickly as possible. For example, if a person is visiting a shopping mall and he has no time, he has maximum 30 minutes, and he just want to visit the whole shopping mall. So we have to respect those anthropological demands on their time saving standards is really important. So for all those who are interested into getting the knowledge about time saving standards, I would like to invite you guys to please study this time saver standards for architectural design by Michael J. B and Donald Watson. So it's available online. You can have a look over that in your spare time and try to look for whatever interests you. And vast podium to stand out as a welcoming building. The building should be welcoming to the guests. So if a person is coming, there should be vast podium inside, outside the building, which can give an idea of great welcome to the guest. So here, as you can see, people are standing. So it's a great idea to just build a podium so that the people can go inside with a great sense that it's a huge building. It's a gigantic building. So that's the idea out here. Maximum windows on the south side is being provided. Most of the buildings are deprived of sunlight on the south side. So we try to provide most of the windows on the south side so that the light can come in from the back of the building, and that might be able to, helpful to actually lighten up the inside structure. Typical straight walls are built, and that's the common thing. Stronger look of the art and innovation in the art gallery, which will be discussed in the coming slides. Parking in the basement to avoid any disturbance due to traffic load. So the parking is provided in the basement so that incoming traffic is not being disturbed from the people coming inside if the parking is on the same ground floor. So sometimes there is a hustle of the cars coming in, cars going out. Similarly, people are coming from the same side as the parking. There can be a conflict, accidents. We don't want to do that. So parking is kept separate from the entrance of the building, which is I guess is a great idea. Let's show you some aesthetic views. So this one is the aesthetic view on the southern side of the building. You can see the walls, these curved walls, which is a dome structure, and these walls and these windows, sorry, is on the southern side. Most of them are on the southern side. The other view of the aesthetic, which is showing some stairs, so that you can just, if you want to go outside the building from the southern side, you can go and have a walk around these green lands, and you can see and click some photos because it's a great aesthetics out there. So this is how the concept is here. This one shows some kind of a sidewalk, and people can try to walk on there, and again the same concept here. This is another view of this building from the, I guess, the front portion, just moving around on the other side of this building. So ground and first floor, this is the plan. So if we are seeing on the seeing the building from the top, this is the ground and first floor. So first and second floor for the British people. So for all others like American and Canadian and all other countries which follow the American standards, this is the ground or first floor. So warehouse has been built on the on one part of this building, because we want to serve as a, we can put it as some kind of electrical supplies like generators and all those stuff into the warehouse. And if there is any supply, if there is any kind of deliveries coming up for the shopping mall, so it can be, unloaded into this warehouse, so that we cannot disturb the environment of the shopping mall. So this can, you see that these kind of, the petals is kind of a similar to the flower. So that's a good idea. So you can see that there's a podium out here. This is the entrance. So you go inside the building. It's a patio, and you see all around. So if you stand in the middle, just close to the patio, you can see all around the building. It's a vast, area, but you can see all around the building. Really, really easy. This is the second floor, same concept, and it's just a mirror image of the first and the ground floor. The basement. The basement actually has a capacity of 400 vehicles. It's a priority parking for energy efficient vehicles because it's a green idea. So we are giving priority to the energy efficient vehicles only. And this or and the basement is also used as to access the, the first and the ground floor and the other shopping malls through the elevators. Most important part, structural design. Maybe some civil engineers might be interested in getting to know how we have designed this building. So of course, the main structural component is slabs, design, building lintels, beams, columns, arches, and dome, retaining walls, footings. And these are the most important thing that I want to discuss with you, but we are not going into more depth of how the actual design was carried out. I will try to explain it, the overview only. As I told you that this building was designed back in 2015, so we have tried to use the load resistance factor design following American Concrete Institute ACI 318 building design, which mostly we have utilized this 1.2 times factor load on dead loads and 1.6 times the live loads. So for the slabs, we have tried to utilize American Concrete Institute moment coefficient measures, and for the arc design, the arches, we have used like Indian standards IS 4090-1947. So structural design for manually was designed for wall, manual structural design manual was used for the wall design. So slab, here you can see it's similar to the any kind of conventional building. So we just divide the slab into small rectangular portions, as you can see here. We try to just cut it in such a way to form a rectangle in there. As I guess if it's 380 square feet of you know area of the slab, and that was utilized for ACI moment coefficient method, which states that the moments is to be distributed into the x and the y direction, and based on those moments we design the steel uh, for the structural loading. And as yeah, so as I told you guys, it was equivalent structural, equivalent rectangular area being utilized to consider the fact of x and y loadings. So x loading out here, y loading out here, so it's just the same concept as similar to any slab design. Beam design, you can see that the bold portions are the beam is the curve linear beams. It's the geometry of the beam, so that can be seen here as I just marked it up. These are the beams you can see, and the beams are designed using LRFD method. And these columns, C1, C2, they were actually designed again using the load resistant factor design, and provision of these columns were was determined using the software and how the load is being distributed. I will show you the concept of the actual design that was done on the software ETABS for this building. And that's how the columns were put there in these places. So you can realize that. So C1, C1, C1 is actually the same columns all around the building, which has same cross section. C2 are those columns which has a little bit higher, higher cross section as compared to the other ones. And the walls, these are the walls. You can see the boundary. So walls are also curved in sections. So the most the actual part to which is challenging is the curved thing to be designed, because it forms kind of an arch action in different directions. So that's the most difficult part to tackle around as far as this building was concerned. But it's not the hard and fast rule. Arch design. So the arch design was done, as I told you, by Indian standard, using the Indian standards. So there were two different cross sectional of the arch that has been designed. So the initial portion, when you get inside the building from the welcoming area, it has smaller arches, and once you go inside the lobby, it has a bigger arches. So 25 millimeter diameter steel has been provided throughout the section, and the Indian standards has been utilized. So you can see that these are provided all around the section here, and the cross section, you can see that it was 42 feet in height and 64 feet in uh, you know uh, in the X plane. So uh, this is how the major portion was designed using the ACI method. So if you guys are interested in actual design of this concept, because it's the not the scope of this project, so you can try to look into the manual called American Concrete Institute 318. It's a building code design that was being followed for this one as well. So there is no difference between the lead building and the other building for the designing aspects are concerned, because it's the conventional design. Yes, we do follow the other rulings, like the kind of other materials, recyclable materials and all those stuff. Yes, we do incorporate those things, but the design remains the same, mostly because the theory remains the same behind. So dome, actually the dome that was I was discussing just previously is actually a shell element, which is just applied load due to the membrane action developed inside it. So whenever you apply a load on any kind of a dome structure, consider you have a cricket ball, you have any kind of a tennis ball, just try to apply pressure from the side, so it will try to distribute the load into the into all sides of the into all direction, I should say. So it's kind of a membrane action that has been helping out to distribute the loadings. Meridorial steel and hoop steel is being provided into the dooms, and dome runs in the form of half hemisphere on the top of each pedal. So you can see in the photo in the background, these are the domes running here. These things are basically the dome, and ring beams are being provided at the periphery of the dome. So ring beams are basically those being which try to restrict the axial stresses being developed due to the membrane action. So it's kind of a similar thing. You just wear a belt on your on your pants whenever you try to buckle up something. It's similar to that, because this pen try to tighten up the cloth. So just to whenever if there is something pressure being created, so it cannot go anywhere. So similarly, this kind of ring beams try to distribute the load in such a way that the dome does not get open. Steel details of the dome was number 10 bar was provided at 225 millimeters center to center, has been used throughout the cross section. So you can see that number 10 bar is being provided all around at 225 millimeters center to center. So this distance is being determined using the design code. We have to follow the design code. And number 16 bar as a hanger, and main bars are provided with number 10 rings at 75. So these ones are number 16 bar as a hanger and being provided as 75 millimeters center to center. So as I told you earlier that we have utilized a software called ETABS to verify the design. Mostly uh, all the design are calculations are taken out using the softwares these days, but you can also verify it using using manual calculations, which we just discussed it earlier. So ETABS is a software which can be used to design the slabs, building, footing. For footing, we use SAFE, by the way, but for this one, we utilize ETABS for design of columns, beams, and slabs mostly. So this one, verified using the ETABS. All the buildings were divided into the member of small integral sections as can be viewed in the. Okay, so yeah, in the coming slide, I will show you the model that was being built in the ETAB. And let's see. So this was my model actually for this project. So these are being the meshes that is being utilized to divide this building into small meshes so that the steel details are accurate. So remember, number 10 bar, number 16 bar being provided in different areas of the of the buildings in the specifically in the domes and all the stuff. So this was being verified. So this is the analysis portion. So you can see these columns and the beams running all around the periphery and inside the building. So this is the central portion. This is the slabs and all the stuff. And the best part of the this software is that whenever you try to run the analysis, it shows all the members which are failing and loading as a red portion. So if it is not red, so that means your building is safe against the loading that you have been utilized. So this is how, it's just an overview how we design a green building. So you will realize that it's not different as compared to the conventional building. Is same, the concept remains the same. However, we try to build other things like the lighting inside the building can be energy and efficient, and the arches utilization of the arches is very important for cooling the loads, because it confines the the cooling air inside the building really in a more efficient way. And that's how the things are here. So if you have any other questions regarding this building design, we can go ahead and take up your questions. You can write it in the comment section, please, and try to share this video with your other friends. And stay tuned, we'll be uploading more videos on sustainable engineering. Thank you very much. Have a wonderful day. Go green.